ecosystem where ideas meet execution, curiosity leads to discovery, and the learning translates into impact.
आता ऐक ना तिथं कोणाला थांबू देऊ नकोस आणि कोणाला काही बोलू देऊ नकोस.
ते उघडेल. Premier institutions in engineering education in India.
How cultural power large circle brings laurels from scientific excellence in prestigious competitions for a short time.
The institute has competent faculty and supporting staff to channelize the student potential. Various activities, academic, co-curricular, and extracurricular, are regularly conducted by the students.
From our vast knowledge of films to top class
आठवून टाकू ना
आयडी कार्ड
our campus
तुझं कोणाचं आहे बघ तुझं एक तिथं
माझे काय
त्याच्यावर टाकून काहीतरी होईल आणि परत बाजूला घेऊन ठेवतो माऊस
संतांनी आपण कोणाला इथून मॅम फक्त कोणाला इथून पास आहे तुम्हाला
अनुकूल माईक कोणत्याचं चालू आहे याचं चालू आहे याचं चालू आहे
of over 8,000 professionals spanning the majority of our students fill coveted positions in top international institutes. Our industry-oriented curriculum and dedicated placements ensure the graduates meet global standards. Our youth come in with this from our territorial students recognize excellence while presenting achievements because graduate deserves a opportunity that brings to those. D.Y.Patil College where teams transfer international where students chant and becomes D.Y.Patil College of Engineering, empowerment of knowledge, building tomorrow's limits together. In the heart of India's industry, where innovation meets tradition, stands a beacon of engineering excellence. D.Y.Patil College of Engineering. Since 1950, on an magnificent 10 in the bustling Bombay by industrial building craft India, affiliated to by realize. Akurdi holistic education that provides lives. Awarded Best Engineering College in Prestigious by Bandyopadhyay. Honored with AAA rating by the 360. And awarded a prestigious 3-star rating by the institution in which you act. Recognition that speaks volumes about how we pursue excellence. State-of-the-art radiology, talented smart glasses,
फ्लॅश
useless knowledge workers, vibrant technology.
तुमच्या टीम मध्ये नाही ना इथून येऊ नका स्टार्ट केलं
तिथं
Very good morning to one and all, and welcome to the IEEE International Conference. As the saying goes, knowledge is the only treasure that grows when it is shared. Today, through this international platform, we are here to share, to learn, and to grow together. As we commence this momentous academic gathering, Let us invoke the divine blessing of the goddess Saraswati, the eternal embodiment of knowledge, learning, and wisdom. Enlighten our minds and guide our journey as we delve into the frontiers of emerging technologies and computational intelligence. I request all the dignitaries to please do the honor of lamp lighting.
तुषारहारधवला या शुभ्रवस्त्रावृता वीणागरगण्डमण्डितकरा या श्रीगोपालमासना
A very good morning to one and all. On behalf of Dr. D.Y.Patil Pratishthan's D.Y.Patil College of Engineering, I, Mrs. Trupti Wagh, IEEE Faculty Coordinator of the Institute, along with my colleague, Dr. Hani Williams, welcome you all for the International Conference on Electronics, Computing, and Communication Networking Automation, co-sponsored by IEEE EDS Society in association with IEEE Pune section. With immense pleasure, I welcome you all to the vibrant city Pune of Maharashtra, known for its rich culture and industrial heritage. Namaskar. Chief guest of today's function, Padma Shri Dr. Prahlada Ramara, eminent Indian defense scientist and technologist. Professor Bandyopadhyay, former Institute Chair Professor, IIT Bombay, and currently serving as Professor at IIT Jodhpur. Professor Annappa of Department of Computer Science of the National Institute of Technology, Karnataka, Suratgarh. Dr. Narumol Chumaung, Faculty of Industrial Technology, Muban, Chombueng, Rajaghat, Thailand. Dr. Amma Buchade, Chair, IEEE Pune Section, Campus Director, Rear Admiral, Honorable Amit Vikram Sir, Chief Finance Officer, Mr. Vipin Sharma Sir, Respected Shri K.T. Jadhav Sir, Principal Dr. Mrs. P. Malki, Vice Principal Dr. Sarnobar, Program Chair Dr. Musmade, Finance Chair Dr. Rituja Deshmukh, Publication Chair Dr. Preeti Patil, eminent keynote speakers, invited guests, media representatives, principals, deans, HODs, faculty members, distinguished authors, and attentive attendees. As per our campus quote, Jnana Dhinam Jagat Sarvam, The entire world is governed by knowledge. And today we all are here together for knowledge sharing and learning by networking, communication, and collaboration. The journey of knowledge is marked by the challenges, discoveries, and meaningful experience. As a simple question from a student also can ignite a research idea. Hence, philosopher Martin Heidegger called all this as a worldhood, emphasizing the interconnected nature of inquiry and understanding. To mark the start of this auspicious experience, I invite Dr. Busumade, Program Chair and Head of the Instrumentation and Control Engineering Department, to present a concise briefing on the conference.
Very good morning to one and all. Good morning. Esteemed guests on the dais, respected Chief Guest, Padma Shri Prahlada Ramarao sir, ex-defense scientist of India, respected Professor Bandyopadhyay sir, IEEE Life Fellow and the former Institute Chair Professor of IIT Bombay, Professor Annappa, a senior IEEE member and Professor of NIT Surathkal, Dr. Narumol from Mugan Rajabhat University, Thailand, Dr. Amar Utsade, Chair, IEEE Pune Section, respected campus director, sir, principal, vice principal, other guests of the dais, principals of various institutes of our campus, deans, CFO, sir, head of the department, participants of the conference, faculty members, and dear students present here and joined us live on Facebook. On behalf of organizing committee, please welcome Professor Bandyopadhyay sir. On behalf of organizing committee, it is my pleasure to welcome you all to the IEEE International Conference on Electronics, Computing and Communication Networking Automation Technologies 2025 at D.Y.Patil College of Engineering, Akurdi, Pune. The event is co-sponsored by IEEE EDS Society and it is in association with IEEE Pune section. As a program chair, I am pleased to present a brief report of preparations of ICEC2NT 2025. It all started more than a year back in 2024, thanks to IEEE International, IEEE EDS Society, and IEEE Pune section for providing us opportunity to conduct this conference in our campus. This is a forum for the researchers, educators, engineers, industry practitioners, and students to share their experiences, new ideas, and research finding on the topics chosen for the conference. We have 5 tracks, which is electronics, communication, control and automation, computing, and networking technologies. In response to our call of paper, in last 7 to 8 months, we have received huge response of 1400 plus papers, technical submissions. We have followed all norms of review process to ensure the quality aspects of IEEE conferences and selected 220 papers for the presentation in this conference in these 2 days. We would like to thank all the researchers who have submitted papers to our conference, and we are pleased to have with us those who are accepted either in physical mode or in online mode. Just to mention about the papers we presented on this platform, we have papers from United States of America, Saudi Arabia, Uzbekistan, and from the 22 states of India. Today we have representatives from top institutions like IIT Delhi, IIT Jodhpur, 5 NITs, and many other top institutions from India and abroad. It is truly exciting to see such a vibrant mix of professionals, educators, and students here today. Dear students, This conference is organized in our campus, in our institute, to provide exposure for you all. This is an opportunity for you to take part in these sessions, discussions, deliberations of the conference. This conference is all about learning from each other, creating space for new voices and ideas. So don't be shy, ask questions, join discussions. Once again, I welcome each one of you for ICEC2NT 2025. Let's have a great start together. We sincerely hope you will enjoy this conference. Thank you.
Thank you, Ms. Marisol. We now proceed to the most cherished moment of our opening ceremony, the honoring of our distinguished guests and speakers whose contributions to science, technology, and education have left a lasting mark of excellence. First, we have the honor of saluting the contribution of Padma Shri Dr. Prahlada Ramarao Sir, an eminent Indian defense scientist and technologist. I will request Rear Admiral Amit Vikram Sir to felicitate Padma Shri Dr. Prahlada Ramarao Sir by presenting a token of love and gratitude. Next, we have the privilege of expressing our admiration for Professor B. Bandyopadhyay, sir. I invite Mr. Vipin Bihari Sharma, sir, to felicitate Professor Bandyopadhyay, sir. May I have a huge round of applause? I welcome. Next, we have the honor of paying our highest regards to Dr. Narumol Chumaung ma'am. I'll request Dr. P. Malti ma'am to felicitate Dr. Narumol. Next, we have the honor of extending our deepest appreciation to Professor Annappa sir. I invite Dr. S.S. Sarnuva sir to felicitate Professor Annappa sir. Finally, we have the honor of acknowledging Dr. Amar Guchari sir. I invite Dr. Bibi Muswari sir to felicitate Dr. Aman Guchari sir. Thank you all.
शैले शैलेन माणिक्यम मौक्तिकम न गजे गजे सज्जनो नहि सर्वत्रम चंदनम न वने वने. It is now time for one of the significant moments of our event. I request our esteemed dignitaries to kindly release the conference proceeding. These proceedings combine the research contributions presented at this conference, reflecting innovation and efforts by distinguished authors. I request all dignitaries to release the conference proceeding. I request all of you to give a huge applause for all the distinguished authors for experimentation business here.
Thank you all for doing the honor. A leader is the one who knows the way, goes the way, and shows the way. Truly, Dr. Mrs. P. Malti ma'am embodies this spirit of leadership and mentorship. Malti ma'am, our esteemed principal, is a dynamic leader and guiding force of D.Y.Patil College of Engineering, Akurdi. With over 30 years of teaching experience, she is a recognized PhD guide in electronics and telecommunication engineering at Savitribai Phule Pune University. A member of reputed professional bodies including IEEE and IEEE, she has authored books, published research papers, and holds patents. Recipient of several prestigious awards, Dr. Malti ma'am combines visionary leadership with academic excellence, fostering innovation, research, and a vibrant teaching learning culture across the institute. May I now invite our respected principal and general chair of the conference, Dr. Mrs. P. Malti ma'am, to deliver the opening remarks.
Good morning, respected members on the dais and off the dais. First of all, I'm very happy that one of my dreams has come true today after 2.5 years. So it is with immense pleasure and joy that I, on behalf of D.Y.Patil College of Engineering, Akurdi, extend my heartfelt gratitude and greetings to all the dignitaries, keynote speakers, delegates, faculty members, researchers, and students present over here today for the IEEE International Conference on Electronics, Computing, Communication, Networking and Automation Technologies 2025, ICEC 2NT 2025. We are truly privileged to have amongst us eminent personalities and stalwarts of science and technology. Padma Shri, Dr. Prahlada Ramarao, Sir, Defense Scientist. Professor Dr. Bandyopadhyay, Sir. Professor Annappa, Sir. Professor Dr. Anurag Srivastava, who is going to join online. Dr. Mahesh Bule, Sir, who is also going to join online. Dr. Narumol, Chumaung, and Dr. Amur Puchade. Your presence today elevates the stature of the conference and inspires our entire academic community. See, the preparation of this particular conference has been started 2.5 years back. And in fact, the committee members, organizers have worked very hard to come up with the first conference on IEEE. From its establishment in 1984, this is the first IEEE conference we are conducting in our college. Since its establishment in 1984, our college has been committed to excellence in technical education and research. Nestled in the industrial hub in Pimpri-Chinchwad, D.Y.Patil College of Engineering has always thrived on strong industry-academia collaborations. The recent achievements of autonomous status from the academic year 24-25 has further empowered us to redesign the curricula, integrate emerging technologies, and encourage research-driven learning. Conferences such as this IEEE conference is a reflection of our vision to be a hub of innovation, research, global collaboration with the well wishes of our Honorable Campus Director, Sir, Rear Admiral Amit Vikram, Sir, and Honorable Trustee, Sri Tejas Patil, Sir, Honorable Chairman, Sri Satesh Patil, Sir. In today's rapidly evolving technological era, the integration of electronics, computing, communication, networking with automation is reshaping the industries, healthcare, defense, and society at large. This conference provides a timely platform for all the scholars, innovators, industry leaders to share their work and inspire further directions in their research. I would like to welcome all the principals of our sister institutes who are here and all the press, media for this conference. I would also like to take this moment to acknowledge the unwavering support of IEEE international officials, IEEE Electron Devices Society, and IEEE Pune section for their technical sponsorship and the encouragement. My heartfelt appreciation goes to the organizing team from the Department of Instrumentation and Control, Electronics and Telecommunication, and Information Technology, whose dedication has made this event a reality. Dear participants, I urge all of you to make of this opportunity, connect, collaborate, and create. Let us engage in meaningful discussions, explore interdisciplinary solutions, and strengthen global academic networks. I hope and also I'm very confident that this conference will pave the way for the new knowledge, impactful research, and innovative technologies that will contribute to societal and industrial advancements. With these words, I'd like to welcome once again to this grand academic gathering. May this conference ignite minds, foster collaborations, and inspire every participant to strive for excellence. Thank you. Thank you very much for the opportunity.
Thank you, ma'am. Thank you so much for your insightful and inspiring opening remarks. You always amplify the support for successful organization of the event and attenuates all hurdles in the process. Thank you, ma'am, for being with us. It is my privilege to introduce Dr. Amar Bujade, Chair IEEE Pune section, to all of you. His scholarly contributions are impactful with 100 plus papers in international conferences and journals with 4 patents in his name. Dr. Bujade has been a dedicated IEEE volunteer since 2006, mentoring student branches and contributing to the growth of IEEE activities across Pune. He is a recipient of Outstanding Student Branch Counselor and Advisory Award of IEEE in 2021. He has significantly contributed to the IEEE Pune section's recognition, including awards like the Region 10 Outstanding Medium Section Award and Humanitarian Technology Activities Outstanding Section Award. Under his leadership, the section secured funding for poverty alleviation projects for farmers, and he has established 10 affordable agricultural labs and healthcare technology labs. Professor Dr. Amar Bujade is currently serving as a chair IEEE Pune section and associate professor at Vishwakarma Institute of Technology, Pune. With a huge round of applause, let us welcome Dr. Amar Bujade.
Good morning, all the dignitaries on the dais. Here, Admiral Amit Vikram, Campus Director, D.Y.Patil Educational Complex, Akurdi, Dr. P. Marthi, Principal, DYP College of Engineering, Akurdi, Pune. Then Dr. Sarnobat Sir, Dr. Sharma Sir, Chief Guest, Padma Shri, Dr. Prahlada Ramarao, Eminent Indian Defense Scientist and Technologist, Dr. Annappa B. Professor in Computer Science, NIT Surathkal, Dr. B. Bandyopadhyay, IEEE Life Fellow, ex-professor, IIT Bombay, then Dr. Narumol, Dr. Preeti Patil, Publication Chair, Dr. Rutuja Deshmukh, Finance Chair, Dr. Musmade, Program Chair, and all team members, participants, colleagues, faculty members. This conference is technically co-sponsored by IEEE EDS Society and in association with IEEE Pune section. IEEE Pune section congratulates and appreciates management and principal of this institute to organize this IEEE International Conference on Electronics, Computing and Communication Networking Automation Technologies, that is ICEC2NT 2025. The conference provides a globally recognized platform for researchers, academics, industry professionals to share innovation in electronics, computing, communication, and automation. It promotes interdisciplinary collaboration across electronics, computing, communication, and automation technology. So this conference has received more than 1,400 papers, and out of that 1,400 papers, only 220 papers are accepted. So this is a quality conference. So there is a significance of electronics, computing, communication, and automation technologies. Electronics are basic building blocks of almost all modern technologies and devices we use today. For example, computers, smartphones, medical equipment, vehicles, power systems, Because of electronics, we can create advanced systems that improve areas such as healthcare, medical instruments, diagnostic machines, wearable health monitors, transportation, electrical vehicles, navigation systems, traffic management. If you see the example of energy, smart grids, renewable energy systems, efficient power distribution, smart systems, home automation, robotics, IoT devices, and AI-powered gadgets. With respect to computing, so if you see, computing is a core technology that allows us to handle and use the information effectively. It enables innovation through data processing, cloud computing, artificial intelligence, and high performance computing. With respect to communication technologies, it connects people, devices, and systems globally, empowering IoT, 5G, 6G networks, and digital transformation. Automation technologies improve efficiency, accuracy, and productivity in industries, homes, and services. Together, this domain enable smart cities, intelligent transportation, sustainable energy systems, and digital economics. They play a critical role in Industry 4.0 and beyond, integrating cyber physical systems and real-time decision making. This convergence supports global challenges such as climate change, healthcare access, and resilient infrastructure. With respect to IEEE, IEEE is a non-profit world's largest technical professional organization with more than 5 lakh members across 168 countries. The theme of IEEE is Advancing Technology for Humanity. Regarding IEEE Pune section, it is established in the year 2010. We are celebrating Crystal Year in this year. We are having 32 ExCom members from academia, industry with vast experience. The section includes 17 technical society chapters such as antenna propagation, aerospace, computational intelligence, computer, consumer technology, electromagnetic, EM-based, that is medical and biology, communications, education, signal processing, industry electronics, instrumentation and measurement, power and energy, robotics and automation, TEMS, Technology and Engineering Society, Industry Application Society. Each society organizes many technical activities that benefits to students, members. There are many opportunities to work with us. IEEE Pune section includes 3 affinity groups such as Women in Engineering, Young Professionals, Life Members Affinity Group. There are 4 special interest groups such as SIG on Healthcare, SIG on Affordable Agriculture, SIG on Smart City, SIG on Energy and Environmental Engineering. We have 2 council chapters, Sensor Council, System Council. We have educational activities, membership development activities, industry relations committee we have. Members also receive funds from IEEE. This year, within 6 to 7 months, our Pune section members received more than $70,000 for different projects, thanks to IEEE. So we are affiliated to IEEE. IEEE is like an ocean through which we can gain tremendous knowledge, experience, and skill through this platform. Once again, I am very thankful to the organizer for inviting me to talk in front of wonderful participants. Best wishes. Thank you very much. And so we'll support this. We are supporting this conference as well as we'll support next conference, which may be scheduled in the month of September 2026. So, thank you.
Thank you so much, sir, for sharing the insights about IEEE's vision and initiative and giving us support from IEEE Pune section. A true leader isn't defined by a title. It is about the impact they create and the inspiration they provide. We are privileged to have such a leader amongst us, Rear Admiral Amit Vikram sir, Campus Director of Dr. D.Y.Patil Educational Complex, Akurdi. A decorated officer from the Indian Navy, sir brings with him over 35 years of distinguished service, marked by leadership, discipline, and operational expertise. having had key role in training, education, and HR management across major naval commands and the Ministry of Defense. He is now channels this vast experience into shaping the academic ecosystem with innovation and global outlook. SIR's contribution continues to inspire both educators and students alike, motivating them to excel not only in academics and research, but also in life skills. We are honored to welcome Rear Admiral Amit Vikram Sir to address the gathering.
Namaskar and a very pleasant morning, ladies and gentlemen. On behalf of Campus Chairman Sri D.Y.Patil, MLC, it is my privilege to welcome all the distinguished guests on and off the dais, delegates, heads of institutes from Akurdi and Jodhpur campuses, faculty and students participating from DIAT and many other institutes offline and through Facebook live telecast on this IEEE International Conference on Electronics, Computing and Communication Networking Automation Technologies, organized by our flagship institute, D.Y.Patil College of Engineering in this campus, which is having a rich legacy of over 42 years. It is my honor and privilege to welcome Padma Shri Dr. Prahlada Ramarao, defense scientist and technologist, who very graciously accepted our request to grace this event. We are truly privileged to have very eminent guests seated on the dais. I make special mention of Dr. Aman Hussain, Chair IEEE Pune section, who has been instrumental in extending all the support and guidance in planning and organizing this conference. I extend welcome to delegates from industry and senior professors who will be chairing the sessions post this inaugural event. My appreciation with gratitude goes to the attendees who print from the print and electronic media and the support in giving wide coverage to the conference. DYPCOE, the host institute having the autonomy, is not only putting vigorous efforts towards international collaborations, but also evolving its vision to foster a dynamic interdisciplinary learning ecosystem that brings together theory, practice, and innovation and prepare industry-ready students' course. The future of work is rapidly evolving, driven by technological advancements, shifting societal expectations, and economic changes. Having the students seated in audience, if you go through the World Economic Forum's Future of Jobs report of 2025, which gives the glimpses into the future job skills, I would like to say that the core skills that are seen essential and expected to become more critical by 2030 was the technology skills, cognitive, and life skills. And they would heavily influence the Industry 4.0 expectations of increased efficiency and productivity. Technological fluency, whether it is AI, big data, or cybersecurity, being comfortable with technology would be no longer optional. Even non-technical fields would demand a basic functional understanding of digital tools and platforms. I am sure that ICEC2NT 2025 would bring together academicians, thinkers, and researchers from diverse domains, facilitating rich dialogue, and would in turn help think deep our students' community towards collaborative learning. Let us use these 2 days to ignite new ideas, spark innovation, and work together to build a strong industrial academia connect, which is a reality and is the need of the hour for a more sustainable, inclusive, and prosperous future of all. At the end, I would compliment Dr. Malti, Principal, Dr. Sharnovat, Dean, Administration, Dr. Musmade, Dr. Preeti Patil, Dr. Rituja Deshmukh, and the entire team of coordinators and students for threading together the planning and organizing this conference. I once again welcome all the delegates and guests to our campus. Happy deliberations and
sir. Thank you for your address. Your words have set the right tone for this conference and will surely guide our discussion forward. Thank you for your timely guidance and support for the perfect execution of the event. We are deeply honored to have Padma Shri Dr. Prahlada Ramarao, a distinguished scientist, visionary leader, and one of India's most respected technologists.
त्यांचं पण नाहीये ना त्यांचं नाव नाहीये थांब.
His remarkable contributions to the field of defense research and technology have been instrumental in strengthening our nation's scientific prowess. Sir is well known for his role as a project director for multi-target handling mobile surface-to-air area defense missile system, Akash, and receiving a national award, Padma Shri, in 2015 in science and engineering. Akash missile system has been inducted by Army and Air Force and is currently in series production. Weapon systems are also being exported. The total production value exceeds rupees 50,000 crores. As a director DRDL, he was also program director for India's submarine launch missile system K-15, supersonic cruise missile BrahMos, which was used in Operation Sindoor, and led the integrated guided missile development program as the chairman of program board and worked directly under guidance of Dr. Abdul Kalam for 25 years. He was the distinguished scientist and chief controller in DRDO corporate headquarters for aerospace system and was also in charge of extramural research, academic and industry interactions, intellectual property, user interactions, and international corporations. Subsequent to his superannuation, he was appointed as a Vice Chancellor of Defence Institute of Advanced Technology, Pune, the only defense university in the country. He has been the president and chairman of many organizations and fellow of many professional societies like Aeronautical, Astronautical, IET, and many more, and also a recipient of number of associated awards. He is a managing trustee of Trust for Advancement of Aerodynamics in India and is in the board of governors for IIT Guwahati. He is a certified independent director, as in many boards. Currently, he is a co-founder and chief innovation officer for Hylian Technologies and globally recognized research of cold fusion. The cold fusion, also popularly known as low energy nuclear reaction. He is revolutionizing the world as the most likely green, safe, and affordable energy source in next century. I now take honor of inviting Padma Shri Dr. Prahlada Ramarao with the great respect and anticipation to bring at his keynote address and open the conference officially with his valuable insights.
Morning to all my young friends and not so young friends out there. Especially, I'm really enthused to see our student community, the youth power was here. Because as you might have heard, I was leading the missile program with Dr. Abdul Kalam was my senior. We went with my boss, whatever you call it. And I had to develop the surface to air missile system with nearly 1,000 young engineers, boys and girls, who are all in their 20s and early 30s. Most of the work done by people like you, who has done these missile programs. So whether you have heard of Akash or BrahMos or submarine launch K-50 or Astra, whatever you take, they are all done by people of relatively younger age because that requires a lot of risk taking. The issue was that when you develop a new missile system and this complexity, what you are talking, it involves a lot of failures. And the younger you are better to take the risk of failures. More your age, you are scared of taking risks and failures. And young people, they don't care. They say, let us see what next we will do. So that is the spirit with which we worked. And the result was, though we took 10 years, we know the mission system. Well, you have another thing to see. And we used to enjoy the Republic Day parade where you see the watch missiles, Akash, BrahMos going on. We used to clap, oh, what this mind said that. So we used to be very happy that we never knew at that time there will be a war and there will be real army, real air force making, firing and saying it's good, you've done a good job. So we were very happy, but it was a good experience and a good demonstration of power of technology. The power of technology, see, as you now heard, it's a non-contact warfare. The only warfare that took place, there is no hand-to-hand custom to custom interaction. All non-contact. It will be the order of the day. Whatever happens to the world, it will all be non-contact. There the role of, see, I have done all the five systems where you have
offline session.
play a lot of role. But what I realized, I'm a mechanical engineer followed by aeronautical engineer. What I saw later is, unless you integrate what you see here, no, electronics, computing, communication, automation, unless they integrate this system won't work. The role of all communication, computer, automation, electronics, major role, as important as aerodynamics and structures and propulsion. So there, because I was non in this domain, I had to learn a lot to make the missile system work. I have to start reading the radars and communication, digital, passive radar, active radar, multi-phase radar, then laser radar, and the communication. All that we did. And there we saw, unless you know the electronics portion, the mechanical portions, integration, then only it would be making a full weapon system. And it's so, even in case of any non-defense also, you take a car today, there's so much of electronics and software and sensors. The body and engine is only a minor component of the cost. So that's why I thought when until Vikram called me, he said, you should come and address. I said, this is an opportunity for me to talk to people from non-mechanical, I am a mechanical engineer, so it's good to talk to mechanics and talk to people. So I took this to good and happy, I'm here with you, and all people are here to understand it. So I thought, let me share my views and my thoughts. I will not go deep into it because it's an important conference, and IEEE support is there. I'm very happy. But IEEE support in this, and I have been in Pune for the last 3 years, and this is my second IEEE event I am participating. So it's good to see that. So I will share my views, and I won't talk much about my missiles programs because you might be the right audience. But the role of IEEE related topics is very high. This is what I want to tell you. So, some of the ideas I take from the future, because I was handling the Defense Institute of Advanced Technology, where we handle various topics which are non-aero topics. And I have prepared something which I thought you will all be addressing it deeper. You will go deeper and wider. I just want to What flag? I just flag the data. You can discuss the next 2 days. So, because I was handling many of these things, my colleague Bijnan Raju was here, so he has helped me to prepare it. Okay. So, I see, actively role is always they're looking at beyond what is known, what is futuristic. So that is how you develop new technology, new sensor, new software, new communication, then new hardware. And when we make a system, see, for example, I made the system, then the airport normal told, I want to verify the system operational in the battlefield where there is a lot of electronics warfare will come into picture. So jammers will be there, some decoys will be there. I want to make sure these systems work in the field when there is a lot of disturbing things happening due to electronic warfare. So this we were not fully ready, but we had a hint of it. So that is why I think we go beyond. So we're not making yourself, we do not know how to handle vastly electronic warfare. So fortunately, there are people in the country, there's a range where you do the testing of systems, and we went to, and I should show it was a good experience, but we successfully crossed all the expectations of the Army and force. Say, yes, what we think is Jamia and all those things is capable of handling such a tactics. Okay. So that is seeing beyond the know. The radar technology, under this program, we made the first phase of a radar in the country, which is a electronically scanned digital radar, fully digitized and fully automated for handling the various activities of the missile system. Also, C4, ICEC2NT, things are there. So radar technology went through a metamorphosis to the defense program. Now, same radars are used in many multiple applications. Same technology is used. So that's how radar technology played a role. And the revolution in radar technology. Radar is not static; it's continuously I made the radar 30 years ago. Today, the radar technology has gone through generations forward. Then software-defined radio. We were talking of software-defined radio as a first model. Today, we produced software-defined radio, and not only software-defined radio, software-defined, completely C4 engine, command control. Everything is software-defined. It would happen. When challenges in radar technology, I will just have one or two challenges we faced and successfully overcame. And microwave photonics. So latest I went into the quantum technology, where I saw the RF and photonics will be integrated. So these are new things happening. Photonics is entering into every aspect of electronics. Earlier, photonics was only taught for lasers and things like that. But today is entering into electronics, warfare, electronic radar, communication. Everything is there. Photonics coming to picture. Then photonics, quantum radars, RF and the photonics, how do you integrate? How do you get the best out of RF, best out of photonics? Then radar technology with plasma antenna, future is coming. Plasmas are going to play a role. And the decoy for the anti, sort of a war situation, how do you handle decoys? Then cognitive radar is the new thing coming up with cognitive radar. Cognitive radar. Both of them cognitive, that's all intelligence integrated. The AI and non-AI, they will integrate the two radars and communication. Then the satellite is a new thing that is going to happen, that we thought satellite only for beaming the TV channels. But the way the satellites are going to play a role, a different role, it is going to be a big thing using of satellites in navigation, in communication, disaster management, whatever way, the role of satellites is going to increase. Defense also going to play a big role. And therefore, we should understand how the command, control, communication will play a big role in handling support related activities, both for defense and non-defense activities. Then laser, recently saw laser plays a big role in not only defense, non-defense activities, but we are going to play a major role in defense activities. And then, of course, passive radar, the new thing coming up, that is, your radar is to be tracked by somebody. So I don't want to beam, I want to radiate, I want to transmit only microwaves. I want to only use the passive mode, I only receive. So once I don't transmit, my signature is not received by anybody. I only receive the signals. By receiving signals, how do I do carry out radar functions? Very big challenge. What is being addressed today, not only in the country, throughout the world, passive radar is going to play a big role. So you will reduce the number of transmitters, but allow any receivers and then take signal from receivers and carry out radar functions. Very big thing. So the foundation required for such activities will be the you should understand them. And it's very interesting to see that biosciences in the next decade, biosciences will enter into electronics, will enter into chemistry, will enter into mechanical materials. So we should see how people are going to integrate biosciences into non-bio domains. This is going to happen. We are watching biosciences, even in materials for is going to happen. Then fluid mechanics, see microfluidics. When you talk of fluidics, there are microfluidics where you have devices which are chip mounted, and those devices use microfluidics. Where you handle microfluidics, talk about how do you handle it, small motions at atom level, molecule level, fluid motion. Then optics and photonics, I told you, all the quantum is full of optics and photonics. Then mechanical engineering will change the new materials, engineered materials, manufacturing techniques, fourth generation, fifth generation manufacturing. Then the integration of platform. See, platform may be satellite, may be aircraft, may be UAV, there's integration. Meteorology, because weather, you are saying weather becomes a part of, people are going to use weather for various applications, both for constructive or non-constructive applications. Space, as I told you, satellite, both. Health sciences. Will health sciences be integrated with electronics, communications? Think of what's going to happen in future. I see a lot of, and both benefits and, I could say, negative activities with health sciences. Then AI, of course, I saw paper in the papers, 70% is AI, this collection of papers. Okay. Radar and communication, I told you. Earlier we used to have radars with all devices, microwave devices, with all huge components. Today is all solid state with small chips coming, and then phaser, I told you, radar after radar, phaser radar. Any continents are either phaser radar, no more classic stuff, good old radar using PWT or Klystron or a microphone, those days as well. Then photonics will enter into both communication and communication. And passive radar, I told you, you will not radiate, but you will receive the radiation from non-defense activities. For example, radio towers, TV towers, any other communication, they are all radiating for various activities. You receive the signal, receive signal, and carry out your activities of tracking, channel, and then intelligence, you can do that. Then the cognitive radar is the highest software driven activity that's going to happen. And of course, we can have frequency movement continuous on the various waveforms. Then the weather will play a big role. We are watching, especially India, the way the weather has played a big role last months. Weather can be a big parameter to be taken note of. Then medical, actually, healthcare and medical, and mobility, everything is today we are all mobility is now. In case the fossil fuel will reduce or vanish or not available, what is your mobility? EV. Will EV sustain? What is required? Can you manage in any other way EV equivalent of that? That is challenge. I told you we are trying to do low energy nuclear reactors where we don't use any fossil fuel and we can manage using hydrogen normally available abundant materials and generate electricity. Therefore, EV can be made available without going into the say, dependence of either solar or wind energy. Then urban life, these are very important. Most of the activities are urban oriented activities. So safety, security, where again actually has a big role to play in safety, security, especially in urban communities, which is the highest density of population. Then he actually EW, actually what countermeasures, both for defense and non-defense activities. And system on chip, I told you, I used to, the first computer we made for a missile was probably the size of a small box. And we have no place to put inside the missile. But today, same computer is a small system on chip. Okay. Then, of course, optical free space communication, optical, different things are happening with quantum coming and entanglement within thing, how the communication will play a role. Then digital devices, with RF and photonics integrated, it will be a new phenomenon. I'm sure I saw some of the papers addressing it. Then multi-band RF, not only you need the same device, can you put multiple bands using RF and photonics? You can change the bands by just playing with RF and photonics. Then the measurements happening at that using microwave and photonic, like I told you, RF, microwave and photonics. System on chip, I plan. Plasma is futuristic and fluidics, including microfluidics. Then mobility is an aircraft or UAV, satellites, aerostats, satellites. So it's already, we have made the first satellites have been made, where you have got a very high altitude balloon or a UAV or whatever you call it, drone, is kept stationary and it will work like a satellite. So it will be replacing a satellite at much lower cost, safer and quicker. You can launch the balloon in probably in hours. So satellite requires weeks. So that is going to come. Eurostar and satellites future. Of course, marine activities will play a role in carrying these platforms. Then ground vehicles. Most of the operations are with mobility. Nothing is stationary. Nothing is static capabilities. And towed bodies, people use instead of parent body, flying body, or towed body to do all the activities. This is going to happen. And you'll be witnessing many activities. So these are all the various topics that we will be addressing, and I saw a number of papers talking about it. I told you software defined radio, and when we started for the Indian Army, we thought we would be new thing. But today, this will be available for commercial use. You can have radios which are defined, you can manipulate while operation, so you can define the programming, or even AI can be used for programming, the software defined radio. And it will be small and it can change the band shape, wave shape, it can change the frequency, change the modulation, real time. So this would happen, and these are things that you will have the single chip with the software integration, which can do wonders. So that's where the paper start being presented. Then the electrical radar challenges with radar where microwave is very wide band, but can you have multi-band radars? And for example, we are trying to see an aircraft carrying radar communication. Can it also do EW activities without any new antenna? So can you integrate EW and radar, and surveillance and radar, sensing and EW? Such things are going to be challenges ahead of all of you. And and of course, we are shown the naval vessels because we are a huge coastal line, so we have to have the naval vessels also for this microwave radar technology. I'm only giving us, you can say, sample of what papers will be there and challenges you are going to face, even going to details. Photonics, I told you, microwave, RF photonics, it's where you can see devices which look like that. You don't have a chip or a device using fluidics. So microfluidics, chips, and microwave all get integrated into new. There is a light source, there is a microwave, real estate, microwave, and lights. All the three getting integrated. We want to be the future. And the quantum radar, I'm happy in Pune, I saw quantum optics taking place, where, including underwater communication using quantum. And there, you are able to, and both the transmitter and receiver can be two separate entities, but you enjoy quantum linked or entangled, then you can control one with the other without any time delay. Almost infinite speed communication can take place using quantum technology. And RF and photonics, I told you, in electronic warfare, we are, because I'm a defense man, so I know more and more plus electronic warfare. But you can see the photonics, how the role, and everybody is concerned with also the war in a field, non-conflict warfare, how you can handle it, EW challenges. Cognitive radar, I told you, the most intelligent way to handle bring the intelligence integrated into the dog. So that it will be, although there is a pilot sitting inside the car and carrying out all the functions. So I mean, he has intelligence, both AI as well as ML put together. So that is the cognitive radar activities that we'll be hearing about the next cognitive radar, cognitive communication, and you'll have to face how to find solutions, modeling, modeling, simulation, and find solutions. And satellite, I told you, is going to play a big role. But all we all anticipate the most of the activities will move to space from ground. Because the ground is very noticed and identified by satellites. So why not have the activity going in the space? So the whole scenario will move from Earth to space. And that's where new challenges will come. And you are your party. You should think how I can handle in space, not when I'm living on the ground. So this is a new challenge because space has different environmental issues, temperature is different, pressure is different, and then the type of effect of atmosphere is so different in space and compared on the Earth. And laser, I told you, will be played big role because the laser has the highest speed of communication. And then how do you handle the attenuation issues? That is where we have to handle what are low attenuation, still high speed communication. So this is a challenge. When you want to high speed communication, then the range will be very high, in thousands of kilometers. And attenuation will be high between layers. So how do you handle contradictory challenges? I want high range, but low attenuation. Then how do you handle it in certain laser sources? So I thought I will give a sample of what is going ahead of you for the next 2 days as well as a decade. And there are a lot of, I can say, very challenging, very interesting activities where unknown disciplines, unknown domains will get integrated to provide new solutions. This is what will happen. And for the young generation here, this is a big challenge, but highly thrilling. Challenge and thrill go together. So this IEEE conference, I'm very happy that so many people I've been meeting people in nice interaction, and my best wishes for all the people, both participants, students, and also the experts who have come from many parts of the world. And I wish you all the best. And I'm sure after 2 days, we will be much more knowledgeable and much more excited to find new solutions for the problem which today you are not even seeing the problem, but tomorrow you will find a solution. So thanks for allowing me to share my thoughts and wish you all the best for all the
Thank you so much, sir, for your inspiring and thought-provoking address and giving us an idea about the various radars and the communication system used. Your remarkable journey from the leading India's indigenous missile programs to pioneering research in clean energy has given us all a powerful message of vision, dedication, and innovation. Thank you again so much, sir. Now I invite Dr. Ritija Deshmukh ma'am, our finance chair and the HOD of Electronics and Telecommunication Engineering, to present the vote of thanks for this opening ceremony.
Thank you, ma'am. Good morning, everyone. On behalf of the organizing committee of IEEE International Conference on Electronics, Computing, and Communication Networking Automation Technologies 2025, it is truly my privilege to propose the vote of thanks. First and foremost, I extend my deepest gratitude to our chief guest, Padma Shri Dr. Prahlada Ramarao sir. Sir, your inspiring words, your vision, and your gracious presence have truly added immense value to this occasion. We feel fortunate to have had your guidance to mark the beginning of our conference. I warmly thank our distinguished guest, Professor Bandyopadhyay sir, Dr. Narumol madam, Professor Annappa sir, for being with us today and encouraging us with your valuable thoughts. We are also grateful to Dr. Amar Buchade sir, Chair of IEEE Pune section, for your support. I extend my sincere gratitude to our Chairman, Shri Satesh D. Patil sir, Honorable Trustee, Shri Tejas Patil sir, respected Campus Director, Rear Admiral Amit Vikram sir, for their guidance and the inspiring address. A special word of thanks to Dr. Mrs. P. Malti madam, Principal and General Chair of the conference, Dr. S.S. Sarnobat, Vice Principal, D.Y.Patil College of Engineering, Akurdi, for their constant guidance and motivation. My sincere appreciation goes to IEEE faculty and student coordinators, along with all faculty members, staff, and volunteers who have worked tirelessly to make this event possible. And finally, a big thank you to all the delegates, participants, and researchers who have joined us from different places. Your presence makes this conference truly meaningful. With these words, we formally conclude the inaugural sessions. We now look forward to the keynote address by our chief guest. Their talks will surely set the perfect academic tone for the conference ahead. Thank you all once again.
Thank you so much, ma'am. As we gracefully conclude the inaugural ceremony, ladies and gentlemen, with the blessing of our esteemed dignitaries, the illuminating guidance of our leaders, and the inspiring presence of our honorable chief guest, it is with the immense pride and privilege that I now declare the IEEE International Conference on Electronics, Computing, and Communication, Networking, Automation, Technologies 2025 officially open. Every great achievement begins with a single step. And today, we take that step together towards knowledge, innovation, and collaboration. Let the session commence and may this conference be the beacon of learning and discovery for all of us. The time to shift the gears and explore the technical innovations that brought us here today, starting with our flagship keynote presentations. It is my great honor to present Professor Bijnan sir, a renowned authority
शंतनू
in control.
नॅशनल अँथम आहे पुढून फोटोज काढ सर्वांच्या पाहिजे तर स्टेजवरती जा स्टेजच्या वरती जा सेंटर सगळ्यांचे मार
IIT Bombay, now continuing as visiting professor at His knowledge and experience shaped the forefront of our field. Bandyopadhyay's research journey spans over 4 decades, with expertise in multi-rate output feedback, discrete time sliding mode control, and nuclear reactor control. His 450 publications and the guidance of 40 PhD scholars reflect his dedication to advancing control system engineering. His achievement has been recognized globally, from the Alexander von Humboldt Fellowship in Germany to the Distinguished Visiting Fellowship of the Royal Academy of Engineering, London. As a fellow of multiple prestigious academies and the IEEE Distinguished Lecturer, he brings unparalleled expertise to our conference. Today, Professor Bandyopadhyay sir will share his insight on modeling and control of large-size nuclear reactor control with computation, the topic that combines theoretical elegance with practical significance for our energy future. So with a huge round of applause, may I invite Bandyopadhyay sir to present his presentation. Welcome, sir.
Sequence change केलं मी.
Dear friends, colleagues, participants, distinguished persons here, sitting now other side, of course. At the outset, I welcome you all to this conference, IEEE conference, IEEE ICEC2NT. It is I am very nice to see that such a big conference is being held in the Pune city. It is the organizer of this conference certainly deserves a very big thanks for organizing such wonderful conference. I understand that from the organizer that there are 1,400 papers were submitted, and out of that only around 200 papers were accepted, which is a very, nice ratio, because it is almost seen in most of the prestigious journals, this kind of ratio. Out of 1,400, 200 papers. So I am sure that the conference proceeding will have very high quality papers, which will be finally published in IEEE. I hope that you will enjoy, all the participants and other people enjoy listening to various sessions of the conference, various papers, and it will be benefited by attending this conference. So I wish you all that a very happy time here in the time of conference, as well as after the conference. So thank you very, very much. Now, today I will be talking here a very important topic, because I have many, many other research areas, but I thought that this particular topic will be very much useful for this kind of conference, which has a deep theoretical treatment as well as a very practical purpose. That is the modeling and control of large-size reactor. This reactor, actually, it is operation at Tarapur, and it is producing 540 megawatt. Two such reactors were commissioned in 2006, and it is producing electricity of 540 megawatt of each reactor. So this reactor, basically, I must give some kind of introduction on me. I am an electrical engineer, but I actually several years ago, I think in early 2000, that one scientist came from ERC, and he told that my immediate of the department, he brought me in me, and he told me that you could like the nuclear control system. Then I was very frank. I told I don't know anything on nuclear reactor. How should I die? Oh, no, it should not fail. You have a background on large-scale system, the modeling and control, and that background. So there was some understanding with that student. Now he has retired as an associate director of ERC and working with some IIT also like me. So then I started to learn the nuclear reactor, nuclear dynamics, a lot of terms, a lot of definitions, a lot of integrations. I tried to learn, and then we started to design the control system. So it has taken several years' time, and then finally this reactor was commissioned at Srivastava to produce electricity. Actually, in our country, we had around 11, 12 reactors of small size. Small size means the physical size is small, as well as they produce the less electricity. Then one of the plans in our country, when we are taught that we should produce much more electricity for a particular reactor. And then this reactor, the pressurized heavy water reactor, which is the Kandu reactor, it is a complete design is done by Indian scientists, Indian engineers at BSc, but you can say this kind of reactor is existing in Canada, so Kandu reactor. It's a different kind of reactor. I'm coming slowly. What kind of reactor? Because such a reactor, if it is built and if it produces electricity, then the large amount of electricity can be obtained from single reactor. So that was the idea in one of the plans of the government of India. And then we started to work to analyze, to model that reactor, and then to design the controller. So I will be discussing some of the things of that reactor, that what is that reactor. So this is, I will be linear model, linearized model, state space model, and then slightly more technique, which is one of my research areas. I am working on this problem for last several years. And several students have got PhD on this topic. So I will come to that topic. What is slightly more control is one of the most accepted robust control techniques in the control system, and why it is so popular and it has been implemented in practice. Then what is nuclear reactor? Just for a general kind of definition, the nuclear reactor is a device in which control fission chain reaction techniques. Control fission chain. Actually, this fission reaction is invented by a German professor 1944 got the Nobel Award for this thing. And due to that fission reaction, now the power reactor is possible. Before that, it was not possible. So due to the fission reaction in the reactor, that has to be controlled. The reaction has to take place in the control data. That is the purpose of control system design in the reactor. So the fission reaction will be controlled. So what is this typically? The nuclear reactor neutrons are absorbed in the fuel. Here the uranium-235, in which undergo fission, resulting in the production of fission pigments, neutrons, other radiation, and release of 200 mega electric volt energy per fission. So this is the thing. One neutron hits the nucleus and splits into two spaces. And that time, the huge amount of kinetic energy is produced, and that kinetic energy is converted into the heat energy, and that is taken out of the reactor and goes to the secondary, and into a power plant, from where the turbine is moved by the steam, that from the heat, and then it produces electricity. So this is the mechanism. Now, there are many other classifications, like first reactors and thermal reactors. What I am talking about the thermal reactors. In India, most of the reactors are the thermal reactors, except one first reader test reactor at Kalpakkam is the only first reactor operational now. Because first reactor, the fission reaction is activated by the first reactor, so safety is very important. In France, they use many reactors on this principles, but we use the thermal reactor. I'm telling what is that. Then the prototype first breeder reactor is our first reactor under commissioning at Kalpakkam. All of the reactors are the thermal reactors. Then another classification is the light water cooled reactor, DWR, PWR, and the one which I'll be talking here, the modeling and control, is the pressurized heavy water reactor and advanced heavy water reactor. Both the reactors I'm working. We have worked, and AHWR also a lot of works have been done. It is completely designed by Indian scientists. I think Dr. Tapak's concept and design, completely Indian design. And PSWR also it is designed in India, but the design principles is same as the Captain reactor, which is done in Canada. Then there are different other kind of gas food reactors, liquid metal, food reactors, all these things, different classification. So basically the reactor, which has a different consisting of the core part, the fuel, moderator, coolant, and control range. Then the detector, the shield, and neutron flux sensor can be import or export. The flux has been detected. Then as of December 23, in India, 23 power reactors are operational, producing 7.5 gigawatt, besides 4 research reactors, to each at PLC Bombay and IEEE and Calpatram for isotope production and research. Most of the power reactors in India are the pressurized heavy water reactors of capacity 220 and 4700 using uranium 235 as a fuel, heavy water as a moderator and reflector, and also heavy water as coolant in separate pressurized high temperature. Now, the two such reactors are operational in Tarapur, as I told you, 2005, 2006, and one such unit is operational at Annappa since 2023. 540 megawatt and 700 megawatt units are by and large identical in construction, but there is a limited boiling in 700 megawatt. In 540 megawatt, there is no boiling of the water, it is pressurized water. These reactors, now while the modeling of such reactor is a very challenging, the main reason is that for a small reactor, there is a phenomena which I will be talking for some time, that there is a phenomena called spatial oscillation inside the reactor, which I will try to explain a little more. And if these oscillations are left uncontrolled, then the whole reactor can blow up. So this was not known earlier. So what is important here, why this modeling is very important of the large reactor, in a small reactor, there are control mechanisms only found. Because there is a change in the flux or there is oscillation that it can detect and it can control the power or flux inside the reactor. So control system is much simpler. It is two differential equations, second order model, and even control is PID control, which are existing only in India. There are 220 megawatt and all this thing. But for the large reactor, this principle will fail. It will not work. That's why the modeling and control of this reactor is very challenging. So there is a phenomenon which I'm trying to explain called the spatial oscillation. And due to that, the reactor cannot be modeled as a ordinary differential equation. It is governed by a partial differential equation. The flux equation, precursor equation, Zenon equation, iodine equation, actuator equation, with a huge number of equations. And it has to be nodalization of those equations that we have. And that's why I will show that this reactor, which is producing electricity at Jodhpur, it is modeled in 70th order differential equation, and then finally it is converted into 70th order nonlinear model and 70th order state space model for which the control system has been designed. So these reactors at physical dimension, it is an 8-meter diameter and 6-meter long, such a big reactor, and in the physical dimension is several times more than the migration length, the slowing down length of the flux coming from, and the diffusion length. So if it is 25 times more than that length, then a typically one control system that you know, then it comes under the large reactor, and one control system will not work to control the power of this reactor. So then the nodalization is needed, the nodal model is needed, and there are several controllers are needed to control the power of every zone. So which I am going to say the large reactor, the neutron production absorption phenomena in one part of the core is not felt in other parts of the core. If suddenly there is a refueling or fault in the flux changes in one part, that is not felt in the other. So the globally, although the total power is the same, but if it is controlled by one single rod, or here the control mechanism is little different, then Although mathematically the global power is controlled, but actually the power is not controlled in each part of the reactor. And there is a phenomenon called flux tilting, and that due to the flux tilting, it can exceed the thermal capacity design consideration of the reactor, and the reactor can blow up. So that's why it needs the multiple controller for this reactor. So these coupled with the non-uniform rate of production and removal of xenon. Xenon is a very important species in this kind of reactor, which I'm going to discuss, necessitates a special consideration of modeling of reactor. Due to this, if the large size, large power is needed, it needs a different consideration. Then I am going to show that how this reactor is modeled, 70th order. I think this is, we have modeled 14 input and 14 output, a multi-variable system. A large number of input, large number of output, and large huge dynamics inside the reactor. So it's a multi-variable control problem. And we have used a sophisticated control theory to control that system, and we implement it on a test bed in US by my student, former student. So reactor needs to be divided into several zones of reactors that is governed by the partial differential equation, and each zone has a flux detector, and each zone has a control device. So it looks like this. This is the reactor front half, the back half, 8-meter diameter, 6-meter long. Then each zone is to be described by a set of equations describing the rate of change of power, concentration of the delayed neutron precursor, because delayed neutron precursor is that when a neutron hits a nucleus, it splits into two spaces, and they again decay in. So that is called the delayed neutron. So as they are neutrons, they are changing the dynamics of the system. That has to be modeled. So it has to be modeled, the power of the flux of the reactor, neutron population, the delayed neutron, and then several species are obtained. One of the species is a large microscopic cross-section, xenon, the neutron absorption cross-section, that is called the transmutation of the xenon, so that dynamic has to be considered. Among the various fission products, the xenon enjoy a special importance due to its large thermal neutron absorption cross-section and long half-life. So the xenon dynamics has to be considered. And xenon is produced from the iodine. That's why iodine has to be considered. So major portion of xenon is formed from iodine, and in large, major portion of xenon is formed from iodine, and only a small portion from direct fission reaction it is produced. Then this is the chain reaction, the uranium 235, then tellurium is dynamic very, very quickly, which is converted into tellurium. The less dominant is iodine, and then it takes about 7 hours to produce the xenon. Slow development. Iodine is xenon, and then it takes several hours, cesium, and then finally the stable species isotopes, which is helium. And a little amount of xenon is produced from this directly from the fission reaction, the very little 0.2%. Major chunk of the xenon is produced from the iodine. So this is a reaction, the fission reaction. As I told, this is invented by Otto Hahn in 1943 or 44. Then an increase, what is the phenomenon of the spatial oscillation? That is very important in this last reactor. An increase in the neutron flux in the reactor results immediately in an increase in the rate of consumption. Initially, the nuclear reactor will push it together, and it is producing electrical power, nuclear power, and that is electrical power, finally. So initially, due to some reason, if there is an increase in the flux, the rate of consumption of then will increase, more flux, more neutron, xenon absorbs them. And then the production through of the xenon will happen. So due to the xenon is not there much, xenon absorbed. So xenon, so what has happened? As the xenon absorbs neutron, then not much xenon is available to absorb the neutron, then you can put the flux increases. As this happens, the net immediate effect is the increased rate of consumption of xenon will further increase neutron flux due to the reduction in absorption of thermal neutron. This process leads to continued decrease in xenon concentration and a steady increase in the neutron flux. And this may continue for several hours till the production of xenon from the iodine comes, which takes 7 hours. And then the reverse process takes place and xenon concentration starts decreasing, leading to reduction in the increasing, starts increasing, leading to reduction of the neutron flux. So this is one cycle, it's 15 hours, half cycle. So total is around 25 to 30 hours. So this kind of oscillation, and that is called xenon-induced spatial oscillation. That is a very important phenomenon in the large reactor. In the small reactor, because this oscillation, I'll show again, in one part, we can, opposite thing can happen in the other part. So there can be a flux change. It's a phenomenon. It is happening in the reactor. So that's why these spatial oscillations are to be controlled. Otherwise, the nuclear reactor can blow up. And even the operator who is starting the reactor and goes home after 30 hours, these oscillations can be unstable and then the reactor can blow. That's why the control system is so designed. So here the control engineers come here and it has to be designed in a way such that the complete reactor is stabilized properly. So this is the phenomenon. I mean, it can be best understood that what is the xenon, the spatial oscillation. Initially, the reactor will be equilibrium, and due to some reason, the flux increases into one part, and then the global control, if there is a single controller, it can be multiple rods, but one mechanism control, single input. Then it reduces, if global controller sees that the total power is more, then it applies the control. And then in both the sides, the control is reduced, and the flux is reduced here. Because the global controller sees the power increases into the power. And then what happens, when in this side, the flux is more, then the xenon absorbs the neutron and increases the flux. So in one side, after a few minutes, one side the flux is more, or neutron population, and another side, if you consider the reactor in two parts. So under the action of global control, then the flux increase phenomenon goes. Basically, in several hours, if flux increases, then xenon comes, produces, and then the flux decreases. So this is 15 hours. In other side, opposite. So there is this kind of oscillation takes place of 30 hours cycle. So this is called the xenon-induced spatial oscillation, and that has to be controlled. So what is done? The control problem of a maintain the reactor power close to the set point of the power demand, maintain the power distribution close to the desired power, and then maintain the fractional zonal powers close to their respective equilibrium. We have applied several techniques, the output feedback technique, because in this, I showed that this is model using 78 order model, and inside the reactor, there are xenon, iodine, precursor, everything, which cannot be, sensor cannot be used to measure those variables. So in outside the reactor bed, there are in-core flux detector by which the global flux as well as the zonal flux can be detected, which are the output. The challenge is that by using those feedback, how can you stabilize the system? How can you control the system? So we have applied several techniques. I will come to that very quickly. The output feedback control, erotic fast output, and sliding mode technique. So in this talk, I present the control of this reactor using sliding mode control. So first of all, the multi-group diffusion equation, very detailed, accurate representation of neutron production, absorption, decay phenomena in the nuclear reactor. However, this model is not acceptable for control studies. So point kinetic model, it is very popular, but it is given oversimplified representation. There is no consideration of the variation of the flux with respect to space. So applied for control studies, we need the large and the medium side and the nodal model. The point kinetic model is to account for the spatial instability, spatiality, i.e. the variation of neutron flux distribution in both its space coordinates and time both. Not applicable to nuclear large reactors in which explicit consideration of spatial effects is must. Hence, a large nuclear reactor is modeled using the nodal approach and what the modal approach. This 540 megawatt has extensively been studied using the nodal approach. So, two energy group is considered, the first and thermal, and all fission neutrons as to appear as first neutron, no upscattering is considered here. So these are the, I will come very quickly on the mathematics of there. So this is the flux, the first neutron flux phi 1 and thermal neutron. So left hand side is the rate of change of flux, and the right hand side, the first term is the d of the grad of phi, which is the leakage term of the flux, and that is the absorption coefficient. Sigma A1 is the macroscopic absorption coefficient, and this is the beta fraction is the delayed neutron, this is the formula. After the fission reaction, that some neutrons are immediately appear, they are known as the prom neutron, and those two species again decay neutron, decay and produces neutron. They are the delayed neutron, and these millions of species, they are grouped into 6 groups. They are known as the 6 precursors, depending on the decay constant. So these are known as the precursors. They also decay neutron. They decay and they produce neutron. So they are the delayed neutron. So beta fraction is the delayed neutron, and immediate production of neutron after the fission reaction, that is called as the prom neutron. So 1 minus beta is the prom neutron, and this is the macroscopic fission coefficient, first neutron. Thermal neutron at this stage, the fission neutrons are produced. This is the inter-energy macroscopic transfer coefficient, and this is the delayed neutron production. So this is the rate of change of first neutron, rate of change of thermal neutron, that is again the leakage term, that is the inter-energy absorption, and this is the inter-energy phi 1 to phi 2. And this is the precursor. At this stage it decays, and at this stage it produces. Then there is an approximation is done that the d of grad of phi, the diffusion coefficient for a large reactor, is almost constant. So d1 is taken out. Then the d of the grad of phi is a del square phi, the Laplacian equation. This is very typical heat equation. The flow of the flux in the reactor, it is a function of time and in space x, y, j. So this term is written in this way, del square phi, and we have the diffusion constant. Similarly for the phi 2 flux is the del square phi. Then the reactor is considered to be divided into small boxes. There is one small box which has 6 labor neutrons, and then neutron flux and other neutronic are represented by the respective average values of the box. And by this method, the partial differential equation is converted into ordinary differential equation. Over that small volume, all the quantities, all the variables, the flux, delayed neutron precursor, iodine, xenon, they are constant over space. This is the idea. This is the normalization. And then the rate of first neutron flow from box H to box K is represented by this. And JR is the neutronic current density, and this is the volume of this box, and this is the area of interface. And then in the Fick's law, the current density is proportional to the flux gradient in space. So that is the JR is converted, and in here, the flux in the space is a finite difference between this flux minus this flux divided by center to center distance, and by this process, the differential equation is converted into ordinary differential equation, partial differential equation, d/d, and that is for only small box. Like that, for all the boxes, it is done, and it is simplified. And then what has been done? That one ordinary differential equation, there are first neutral flux, and this is the thermal flux. The both there are 14 zones which have been several zones it is divided, and it has been found if the reactor is divided in 14 such zones or boxes, then it simulates, it matches the benchmark result of this reactor, which is published by some Akurdi Sanjay research lab, that if such situation is created, the reactivity change, reactivity size, then this model is validated with the benchmark result. So there are many zones it is divided, and finally it was concluded and it was arrived at that 14 zones are sufficient to represent. And each zone has two equations. Then that time we were visiting the research lab in Stuttgart, a nuclear research lab. So these two zones, these two parts, again approximated by an 1.5 theory, and an equivalent flux for every zone is represented like this. So there are 14 zones, so 14 flux. Then, by these approximations, the slow neutron dynamics at steady state is 0, because there are slow neutron. So with this, these coefficients are obtained, and then finally, this approximations is useful for determination of the coupling coefficient, macroscopic cross section, and other parameters required in one group equation. So finally, the flux and the power are algebraic, and this is the power equation of one particular zone of this reactor. So there are 14 such zones, so 14 powers, ordinary differential equations that represent this dynamics of the power of this reactor. Then similarly, the precursor, this is the further simplified, and then this equation, the power equation and the precursor equation. And there are 14 zones, so 14 power equation and 14 precursor, so 28 equations. And then the reactivity and the multiplication factor, the reactivity is related to that, the ratio of the neutron production to the present generation to the previous generation. That is the multiplication factor. If KH is 1, then it is a critical. So if K is greater than 1, supercritical. If K is less than 1, a subcritical reactor. KH is 1 is maintained, so reactivity is 0. So reactivity increases, then control mechanism starts. So this is the, in terms of power, this is the reactivity, external reactivity. This is the reactivity due to the xenon, because xenon absorbs neutron, so it changes the reactivity. That is the internal reactivity of the reactor. So these are the two equations for each zone. And now the iodine, after the fission reaction, the iodine is produced. So this is the yield part fission. This is at this rate, the fission is taking place. And gamma I is the yield of iodine part fission. So this is the rate of change of iodine, is the rate of change of production, and then iodine again decays at this rate. So net rate of change of iodine dynamics is this. And the iodine produces xenon. So this part, the way the iodine reduced, the way the xenon produced. So this part is added here, rate of change of xenon production. Xenon directly produced by the fission reaction. Xenon decreases on its own, and this is the transmutation of the xenon. That is the most important. The xenon absorbs neutron, and it changes the reactivity. It changes the neutronic population inside the reactor. So this is the iodine and the xenon. So these are the two further quantified using this variable. Then DH, DIH, DT, DXH, DT. So there are 4 of them each zone. So there are 14 and 56. Then the reactivity is a constant. So how this is changed? This is why the reactivity zone is directly proportional to the water level. Each zone in this reactor, the rod is not inserted. There are water jet system compartment. Water level is controlled. By level control, ordinary water, controlling the neutron population. because ordinary water absorbs the neutron. So ordinary water level control, there is a valve and the flux is detected, and then it goes to controller, and controller changes the valve, it applies that signal, valve can open and close, and then more or less water is applied to that tube, and by which the neutron population is controlled. So this is a control mechanism. So this is a formula which is the reactivity is proportional to the level of water, and level of water is controlled by the signal to the valve. So this is the control. So there are another 14 equation. So there are 5 equation for every zone, and there are 14 zones. So there are 70 ordinary differential equation which represents this dynamics, and which is modeled using 5 years time by several PhD students and come to that. So this is there are each zone one power equation, and of course precursor there are 6 if you consider one group, then one precursor, one power, one iodine, one xenon, one actuator device. The valve signal is applied to the valve, it changes the level of the water, and level of the water changes the reactivity of the control of the reactor. So there are 5 such equations and 72 order online model. So operation of the reactor in steady state. Total power is the summation of the zonal power related to the precursor iodine or in equilibrium. So then incremental change in the control valve, and these equations are linearized, and they will be linear. These are the normalized iodine, xenon, precursor, and these are the level of the water, and these are the zonal power. These are the control to each valve, and this is a normalized zonal power. So this is the state space model of controlling the US normally familiar with this kind of states, linear state space model, which is obtained by linearizing the nonlinear equation at 2 power of 14. Now this is the system is this linearization process is shown, the linear model, and unstable model, high order, polycyclic stiff system, 2-time scale system. So system is decomposed into slow model and the fast model. Several exercises have been done. System response should be observed for hours to conclude the performance of the controller into the xenon oscillation system is controller xenon observability. Then many techniques have been applied. I will show you what has been done as this work. One of the things which I discussed here, because this is one of my research area, the slide mode control. The slide mode control actually, it is invented in 1950s by Soviet Union, by Professor Leonov and Professor Akurdi. Both have, more with us last year or 6 years ago. Both have died. One is given the title of academician in the Soviet Union. It was academic historian, the Eminent. And Akurdi was the highest award of Lenin's for the invention of this technique. And this technique was first conceived in 1950s. And it has become so large now, I tell, that this variable structure stabilization of a system by discontinuous variation. And it can reject the statics. That concept was not there. So that is all about the variable structure control. And as the right-hand side is a discontinuous, you cannot solve the equation using ordinary differential equation. So Filipov had given a method how to solve such equation. So it is a system with the right-hand side is continuous. So this idea was so much prominent that IEEE in later, it was first published a paper in 1977 by Turkey and Islamic paper, and it was confined in the Soviet Union for several years. And after the writing of that paper in English language in IEEE Committee Control, it sparked research interest all over the world. We would like to know what is that, how it implemented, and it has subject has become so big that IEEE recognized, and in control system society, there is a technical committee on variable structure systems like control. And that committee is responsible to hold a biennial workshop, this conference cycle, every once in 2 years in all over the world. So we are fortunate that I held this conference and I am all So every once in a 2 years, 12 and 14 in France, 16 in China, 18 in Australia, every 2 years. So at present, the next year it is going to be held in Zeta in the UK. So all the research on slightly more for 100 of us, and if very young researchers can do research and they exchange their ideas in this platform, and then some of the selected papers are published at the standard level. And the rest are published in IEEE experiment. So this is the technique which I applied in this model, in this reactor model, the simple control structure, and the variable structure control. The idea is that discontinuous control. Why discontinuous? The discontinuous control, no other control has that property. If there is disturbance in active in the system, then this discontinuous control, theoretically, it completely rejects it. So it doesn't depend on the performance, does not depend on the study. That can be on so forth. The variable structure system is slightly low control, and it slides along a node, along a line, a plane, and that closed loop dynamics is completely governed by the parameter of the design parameter of the hyperplane. This technique we applied in several situations: reactor, reactor flight, missile control. My student in the Bule, he applied this technique in missile, in DRDL, where Professor Dr. Kumar was working. Some student is applying this missile perspective, the sliding load control. So several applications have been done. In Israel, they applied in the integrated guidance and control this technique for several applications of this technique in the real life, because it is a very simple technique. So there are sliding mode, once a sliding mode, we do the advent of the computers and microprocessors. It is discrete also industrial power. So we have done certain things of discrete control, then the protection of initial state, sliding surface, and then it maintain the sliding surface. Control is can be planned by ensuring sliding mode control. So this is the disturbance dissipation and discretization. Then it is done this kind of state output control. Here the multiple question comes, because we can recover the state only by measuring the output several times in one episode. So in this implicit way of observer, you don't need a dynamical observer like real one. So by measuring the output, yeah. So this is the, I'll quickly run down. So this is a reaching law, and control is applied in three simulations. So this is particular. The power, manual transient, initial power mismatch, and external disturbance. So first simulation is done. The 1800 nuclear power, 1/3 is the electrical power. So 1800 megawatt. How does the performance of the controller? 1800 megawatt is converted 10 megawatt per second. The demand is changed after 18 seconds. 10 megawatt per second. And then the control action, new demand after every 10 seconds. I am changing the demand after 18 seconds, and then it is held constant. Then it shows how this control acts, and it brings the nuclear power to the new demand, 1620 megawatt from 18. So this is one such. It is in 90 seconds, it comes 0.4% of the demand. In 1500 seconds, it comes to be more than 1.4% of the demand, and in 3000 seconds, it comes to the plus minus 1%. Then there is a concept which is the consultation gets along the time, but it's still is the role of the hour time to state. So actually, then there is a concept called tilt, axial tilt, side to side tilt, and block load. Like reactor, one power, another power. Then differentiate and normal points. How the fields are. So that is one simulation. That is the initial power, there is mismatch, and then the control is applied, then how the fields are. It can be shown that the action and the side is 2% from the final value and 0% of the where the desired initial condition is.
this institute. Good morning. Good afternoon. Okay, good afternoon. That's what smartness I want from you. Good afternoon.
Hello? Good.
We need smart students like you
Okay, charging some.
to use the technology for the right purpose. We have been hearing a lot of discussion, articles.
Staff से मार ले
Students started using ChatGPT, they're cheating in academics. But I say, use it with your smart ways.
बस मजे तो बस रही है आराम से बस ना
Whatever technology is coming is good for humankind. The way we use it, it determines whether you are smart to use it or dumb to use it and caught by our teachers or the society or whoever. So, as students, go and use the technology available and come up with a new technology which will beat the existing technology. So I want you to build a new chat GPT or whatever other tools which will challenge the existing technology. With that, let me start today's topic given to me. Enabling collaborative AI with federated learning and decentralized models. We have been hearing or using centralized models, centralized technology for several years. And in recent years, we have been developing and using technologies which works in a decentralized manner. Started with cloud computing and various other technologies came which harness the power of decentralized approach. So in this topic, we'll give 30 minutes. I'll try to cover fundamentals, architectures. I'll not be having too much mathematics like professor from IIT was explaining, which is required as a computer science engineer or circuit branch or any engineering student. You need to have mathematics background. I'll not go in detail about that mathematics. The motivation for this talk or decentralized computing or whatever technology you are developing and using today is because of the new oil data. Right? You've been hearing news because of oil we are buying, India is buying, we are in little trouble that we will face with and try to counter it. PM is intelligent, smart enough to address all those issues. But having said that, data is the new oil. Global data is doubling every year or so. All of us are generating a lot of data sitting here. Terabytes of data we are generating sitting here in this room. 80% of data generated at the edge, not at the cloud or only at the internet. This is at the edge. The device what you use, device what you interact with, including your mobile phones, including your intelligent devices like this, they are generating huge amount of data. But the question is, can we use this data for the benefit of mankind? Addressing those technological issues, what we are facing today with this huge amount of data what we are generating. Mainly bandwidth, latency and privacy. A lot of hardware technologies and innovations came up to address these issues, but still we are in the nation state to address it fully. I'll not touch much on the first two aspects. My topic is basically on the privacy. The current day's application pull and the data locality requirement. As data sets grow in size, applications and services migrate towards the data rather than moving the data to the application. Gone are the days where we are transferring data to the cloud and trying to make meaningful use of the data at the cloud. As you know that the file is increasing, we can not afford to move that huge amount of data to the cloud. So the question is, how can we process that at the edge? It also leads to bandwidth and latency constraints. Obviously, when all of us start using the Wi-Fi in this, we face the trouble in sending the large files, uploading or downloading large files. Same thing happens in the cloud. Regulatory and privacy challenges. Government comes up with their own regulatory compliance, like many governments are saying that the customers of that country, their data cannot move out of their country. You may provide the service when they are outside the country, but their data should reside in their own country. Like that, there are several regulatory concerns laid by the different governments. We need to follow that. So this processing at the edge, storing at the edge, trying to solve this concern of privacy. Having said that, can data live at the edge? How many of you say data can live at the edge? Raise your hands, students. Can data live at the edge? What's your answer? I don't know what we are doing these days. When I was a kid, or when all of us were kids, we are asking so many questions, starting from parents at home, at the school. The teacher was so patient enough to answer even silly questions. But these days, even though teachers are very happy to answer the questions, students are not smart enough to ask questions or answer questions in the class. Come out of that by asking questions. Don't feel as if you don't know the concept or the details of what you're asking, that's why you're asking. So don't be ashamed of asking questions in front of anybody, in front of even a kid. Sometimes kid may be knowing more than what we know these days in different aspects. So yes, data can live at the edge to some extent for improved latency, working offline, meaning to say that when you're not connected, that intelligence available in your mobile phone or any edge device can do some processing and give you some output insights. Only when it is required, it can connect to the net and transfer what is required minimum amount of data or inference from the data what it collected locally. And it improves your battery life of the edge devices and privacy advantages. Like many of your mobile has inference engines learning to infer what you are typing. You might have typed only 2-3 alphabets, but it suggests you what is the possible word or the sentence, completion of the sentence. You might have seen in your Gmail or various other tools. So that does not require continuous internet connectivity to your device at the edge. Next, the question is, why federated learning and edge AI at the edge device? Because it improves data locality, security and compliance, and it enables collaboration. Most of the devices at different places can contribute to the solution what we are giving to whatever technology you have brought in. So can we use, including human collaboration and device collaboration, to improve the result what you are getting from that applications? Enables learning across distrustful or siloed parties without data sharing. The concern what current days machine learning or deep learning algorithm face is data, especially in medical domain. Many times, many of the PhD students go with a problem of solving a healthcare issues, but they come up with a problem. Sir, I can't get the data from hospitals. They say so many steps. So can we come up with a solution addressing concern of these PhD students or researchers and the concern of the hospitals or the patients? Yes, federated learning and HGI can address this problem. Edge-centric AI architectures will solve this problem of privacy and solving the data requirement for your deep learning algorithms. So trade-off here is you have cloud, fog, and edge. So if you see that pyramid, number of cloud servers is obviously less, much less compared to fog servers or edge computing devices. So latency, faster insights closer to the source. If you're able to solve that problem to some extent at the location where the data is generated, latency problem is solved to some extent. Privacy, sensitive data, these hospitals need not move the patient data to the server at a remote location. They can process at the local site without revealing to which patient this data belongs, or even not moving a bit of data about the patient to a remote server. Cost, obviously it will reduce the cost in terms of bandwidth and storage expenses. So that comes federated learning. Federated learning is a machine learning setting where multiple entities collaborate in solving a machine learning problem under the coordination of a central server or service provider. For example, like that, most of the advanced medical institutes or engineering institutes all over the world is trying to come up with a solution for AIDS or cancer. They want to collaborate. Since the data, what they're having may not be same. The patient data at Indian scenario may be slightly different from patient data from Australia, UK, USA, because of lifestyle, because of climatic conditions, various aspects. They want to come up with a solution for these life-threatening diseases. Can they collaborate without they sharing the data? Yes, it is possible through the concept of federated learning. Each client's raw data is stored locally and not exchanged or transferred. Instead, focused update intended for immediate aggregation are used to achieve the learning objective. So your deep learning algorithm needs to learn from this data from different locations all over the world. What makes people prone to heart attacks, cancer in India? What is the major cause? Your machine learning algorithm wants to learn from this, bring the hidden insights from this patient data. Likewise, data from maybe a scientist in India came up with a new algorithm to extract this hidden patterns from the Indian patients. Same thing you want to test with the data from Australian patients. He can send that algorithm model to the hospital or the organizations at Australia, UK, work on that data, run that model on that patient data, then come up with the aggregation data about insights of those patients' characteristics, how they are treated, how the treatment went, all those things they can get it sitting in India without transferring any patient data from UK or USA to India. That is the power of federated learning. Again, as I told, without going much into mathematical, I'll give you a brief about steps involved in FL. In the first step, that we call it as step 0, we initialize the global model. We initialize the global model at the central server, or in some cases, we may have a few distributed servers coordinated with each other. That global model is initialized at the central server on step 0. Send model to the number of connected devices at different organizations anywhere in the world. That is step 1. You see, model moves, not the data, and the direction is from central or few group of distributed servers to the location anywhere in the world, including IoT devices, servers at different locations. Basically, where the data is generated. That example of hospitals, you go to the servers at different hospitals across the world to work on the data of those patients. So that is step 1. In step 2, at individual locations, this model will run over the data stored there or generated there. The model is parallelly run. So you get the benefit of running that model on all these data sets simultaneously. Then in the step 3, return model updates back to the server. Weights of those models, learning from that model data, running the model on the data, will be sent back to the centralized server. Then at the step 4, aggregate model updates into a new model. The centralized server updates its model based on the learning it had from data from various locations across the world. You know about different types of learning in machine learning and deep learning, different algorithms. Using that, it will update the new model, global model. Then, if it does not converge, then it repeats these steps. So steps 1 to 4 will be repeated. Step 1 to 4 are what we call a single round of FL. The global model parameters get sent to the participating client in the step 1. Then step 2, it runs or trains the model local side, the local data. They send the updated model to the server in step 3. And step 4, the aggregates are used at the central server to create a new version of the model and repeats if it does not converge at that stage. So this is the mathematics behind that. There is an algorithm called Fed average, which uses averaging data received from different clients. Again, here local and global objective can be slightly different based on the type of data they are using, the size of data, and the power of those computing infrastructure. So you cannot send 2 GB data. They cannot work on same type of data, same size of data at every location. Based on its capacity, size of data, there can be slight variation in the local models, local objectives. So goal is to find X that minimizes the global objective. Maybe it is accuracy of identifying whether the image is cancerous or not. In each communication round, send the current model available to the available client. Again here, the model is flexible. If there are 100 clients available at that moment, it will send a model to 100 clients. If there are 20,000 clients on a computational intensive model, you need more clients. If there are more clients, you send it to more clients. So learning becomes faster, learning becomes more effective, and you don't face any problem of data here. If there are community clouds or community of organizations trying to help this research, your research outcome will come in short time with fruitful results. In the edge hierarchy, you have devices, fog layer, and cloud layer. So the trade-off is latency is very less at the edge layer or edge level. It is too high at the cloud. For you to send data, capture data from your IoT device or the mobile device to the cloud server all the way at Delhi or other countries, it takes time. Even though it doesn't take minutes or hours, even that nanosecond matters a lot when you are working with a large, complex problem. So at edge it is too low compared to cloud. That's why federated learning is gaining popularity these days. Compute power, again you have a lot of compute power at the cloud server. It is too expensive and powerful, but your IoT devices, sensors are very low in compute power, but it can capture real-time data and give it to you. Data control, it's maximum. You can decide what data I need to capture, store locally, and send it to fog nodes or cloud nodes. You have more control, granularized control at the edge level compared to concerning your data at the client level. So maximum control at the, like for example, if this hall is having some surveillance camera installed, some 5-6 cameras, it may be capturing the video at this point, and it notices that there are changes in the frames it is capturing every frame. So it sends it to the local fog server in your LAN, local area network. It determines whether to keep that frame or not. Since there is a change in the frame, it stores locally in the fog servers, and maybe for processing it sends it to the local cloud servers and further to other servers. But after 6 p.m. till next day morning 7 p.m., those cameras are capturing the image, but it does not see any change here. Between two frames, it does not see any change. It's closed. There's no light, nobody's inside. There's no point in sending those images or frames to your local server or remote server. There's no point in that. There's no change. If somebody is trying to enter this or steal something at midnight, there may be change in the frame. That time, it needs to send that the image and alert the security people. Otherwise, it's not required. So, if that little intelligence is there with these cameras, then you're saving a lot of energy, a lot of bandwidth, and useful processing. So you have a lot of control over these devices compared to their computational power and latency model. So this is about the comparison of cloud, fog, and edge computing. Then comes the federated intelligence, where distributed agents learn running over different devices at edge or fog or cloud to infer jointly. As I showed in the first slide, collaboration is the need of the day. Whether it is for research or coming up with new solutions, new medicines, research is the collaborative research is the only way. So federated intelligence is an extension of FL from modern training to collaborative decision making, moves beyond just sharing the weights, enables joint inference, reasoning, and adaptation. So We have collaborating agents distributed across various IoT devices and AI nodes, cooperate while keeping the data local. Adaptive intelligence, agents continuously adapt, learn from local environment, and share the updates. If there are changes in the patients during rainy season or winter season at different places of India, it collects the data and try to fine tune, learn from this data and fine tune the model. So adaptive intelligence, privacy preserving, data remains decentralized at the local site. Resilience, no single point of failure. That is the main strength of decentralized computing. Robust to network disruptions. Even if D.Y.Patil College announces 3 days holiday, other servers are running, but other collaborators can exchange their data even if these servers are not sending the data. Others can work without any interruptions. Cross-domain applications could be any applications they can name smart cities to industrial IoT. This FL intelligence will be the future lead. So architecture, federated intelligence is much more compared to the conventional FL. So architecture, we are moving from centralized to decentralized. You notice here, data flow and parallel computing happening at the same site. Even if in that example, 3 of the nodes fail, one can serve you, one node can serve you. Whereas here, it does not happen. All of them have to be hierarchical edge to cloud coordination. So, as I told, if edge devices can have little intelligence to process data locally, it saves a lot of bandwidth, processing time, and meaningful insights. So, edge to cloud, we have fog servers in between cloud and edge, which can manage the intermediate processing. Only when you need high-end computing and coordinate global data, you can send that update to. Suppose you are dealing with only Indian data and to come up with the Indian fog servers can handle that, and few of the Indian cloud servers can handle it. Comparison matrix, centralized and AGI, and federated intelligence. You see, except latency, all other parameters it scores high. That is fault tolerance, scalability, or privacy. F5 scores high compared to the conventional centralized or AGI. So here, as a researcher, our task is to address the issues in implementing or designing new solutions with the F5. 3 major aspects we need to consider here. One is data heterogeneity. Second one is communication heterogeneity. And third one is computational heterogeneity. Data heterogeneity deals with different types of data, formats of data, different attributes. Like I told, the parameters what we collect in India from the patients may be slightly different. Its scope may be slightly different from the patient data we collect from other countries. So we need to deal with that, come up with the models or technologies to address these 3 heterogeneity aspects when you are coming to solutions for adopting F5. Complete. So these are the challenges for those who want to work in this area of F5, data imbalance. Many of the researchers are working and there are several solutions available. But still, we need to address several inherent problems with this. System heterogeneity, privacy, expensive communication. Even though we are discussing about 5G, 6G, still it is expensive when you say moving large amount of data from one location to other location or storing, processing. So, we need to have different layers to address this. Not only at the edge layer or the cloud layer. To address device heterogeneity, we are collecting data from different devices, different capacity, different types, then models, different types of models, different layers, hidden layers, different parameters, hyperparameters. We can think of different applications. They name any application, you will find one or the other way of application of FI in this. I listed several applications here, including language in your mobile phones to enhance the pharmaceutical research. This is one of the paper you can go through which discusses about the recent developments, including federated optimization in heterogeneous networks. They are trying to address this issue with a platform called, framework called FedProx. It discusses about stragglers in the networks, which delays the computation, delays the decision making, and they contributed in terms of convergence guarantees and more robust empirical performance. As I got it from the organizers, I'll not go into details about this mathematics. So, we need to have different models to address these issues in federated intelligence, lightweight and deep models. Since what model this laptop can run cannot be. Same thing for IoT devices, smaller devices, or same thing for high-end computing servers at the cloud. So we need to have lightweight deep models to address these issues. Then we need to have variations in the existing algorithms. They proposed algorithms called GPDT, gradient boosted decision trees, variation in the decision tree model. Then tiny model, which can run on different types of devices. Ultra low power, which consumes less power. The machine learning models on which can run on microcontrollers. So we need research in this aspect. And resource adaptive and personalized FL, which can adopt itself based on the capacity of the resource, availability of the resource, data size. So we need more personalization there in these models and learning. So this is what emerging research directions in this particular research problem. There are research results coming, attempts are being done in terms of neuromorphic hardware, photonic chips, and different models, cross-model federation of machine learning models, then combination of different models. So, go through this. I've given details about this new research directions here. So, we need to address these open challenges in edge federated learning. The need is transparent privacy, budget accounting that regulators and practitioners can trust. We need trusted models. Then we need standards and APIs for deployment, monitoring, and lifecycle management of FL at scale. We are not able to address the scalability issue to the fullest extent FL as on today. And with the evaluation, automating updates while ensuring consistency and robustness, fairness across the clients. Fairness is one of the important issues with your machine learning model. And those of you are interested to take this learning forward to do a serious research, you can look into this links. There are tools like TensorFlow Federated, Shift from Google and various other organizations, and there are seminars. There's a tool called FATE, Support Federated AI Ecosystems, TensorIO, and there's a fantastic tool called Flower, which this particular group gives you everything for you to start for federated learning, including a set of tutorials and GitHub repository which explains how to set up a federated learning setup and in fact small examples of running an application and getting the solutions. Go through it, those are interested to take it forward. And there is one very best paper, survey paper, which gives the details about this FL and FL intelligence. More than 50 authors contributed to this. First, go through this paper to understand this in a detailed way. Then there are seminar series happening on Flow. Subscribe to this seminar series. You get the link.
Last level.
Hear about the current research happening in this area. Every now and then they'll be sending links to you to attend to seminars, and there are a lot of videos and slides available in that website to understand this. So, to stop here, the key takeaway or understanding here is we cannot only go with the centralized computing scenario. We have to move to adopting to decentralized scenario, even at the edge level, to process data. Challenges. Brand challenges still remains. Communication efficiency, privacy guarantees, and device data. So outlook is our scalability, trustworthiness, and energy efficiency for data ecosystems. With that, let me stop here. Thank you for all of you. Thank you. Thank you, Anurag. And those who are willing to collaborate in any way for the research in this domain, kindly contact me immediately. I'll be happy to collaborate.
Good afternoon.
Thank you. Yeah. Yeah.
Thank you for this presentation. I had one small question.
Okay, go ahead.
You said that the model moves to the data, not the data to the model.
Exactly.
So initially, when the model is there, it needs to be trained on something. So what parameters do we consider to train it in such a manner that whatever data it goes to on different clouds, different places, it can avoid being noisy? So what initial parameters do we train it?
Won't start problem. Organization, if you start this model, they'll be having at least some data, or you can generate some synthetic data. You can train the model initially. Then you can transfer it to other locations. So if you don't have any data, you can go with the generation of some synthetic data to start with.
If we start with any sort of data that can lead to discrepancies later.
Yes, exactly. That's why we go through several iterations. Not only one step, several iterations, till you are happy with the performance. Or you try to change the model, fine-tune it, hyperparameters, all those things. Yes, it needs a lot of rounds to come up with a solution which is acceptable to you. Thank you, thank you. They will have to ask questions. So don't hesitate to ask any questions. Don't think that the question what she is asked is silly or great. She doesn't know, that's why she could not understand that concept clearly. She had a critical issue of the data for the first model when you initialize. A good question, thank you.
Comprehensive overview of federated learning and edge computing. We will now have the last keynote of the day of Dr. Narumol Chumaung. She is a distinguished academician and researcher in information technology and digital media. She has served with dedication at Mumbai Chumaung Rajabhat University, Thailand, in the roles of Director of the Research and Development Institute, Assistant Chancellor, and Head of the Department of Digital Media Technology. With a PhD in Information Technology and International Research exposure, her remarkable contributions into the international publications, research projects, and awards are immense. Her topic for today's discussion is Advanced ECG Analysis Algorithm for Cardiovascular Disease Classification. With a huge round of applause, let us welcome Dr. Narumol Chumuang. Good afternoon, everyone. Distinguished Mr. fellow researcher, Bryce Bule, and all participants. It's an absolute honor to stand here at the IEEE Electronics, Computing, and Communication Network Automation Technology 2025 in the vibrant city of Bule. This conference is more than just a gathering. It's an outpost where ideas, innovation, and inspiration collide. I'm truly excited to share our journey on advanced ECG analysis and working for uh, cardiovascular disease classification. A topic that not only reach discovery of technology, but also carry real impact on human life. Thank you, IEEE and the organizing committee for this opportunity. And thank you for all of being here. I promise the next 30 minutes will be both insightful and inspiring. So cardiovascular disease isn't just number. It's a right. Every ECG line behind signal that could mean early action or a mistake. Shared with AI and advanced algorithm, we can see what the human I cannot. Today, I will share three things why this matters, how we build it, and what is meaningful passion. So, let me uh, the motivation of CBD is still the world. Number one, fuel. Uh, 18 million lives lost each year. They from around 6% sick rise every hour. They lie early detection on critical with the aging population. Early and accurate diagnostic is critical.
This motivation us to develop a smarter, more accurate ECG analysis system. So cardiography or ECG is one of the most widely used tools for diagnosing heart conditions. It is non-invasive, cost-effective, and provide real-time insight into heart health. However, ECG interpretation faces challenge variability between pattern, noise in signals, human interpretation errors. Their AI-driven network become increasingly important. And this research focus on analyzing ECG signal to help classify cardiovascular disease. The conceptual framework starts with correct patient ECG data, then with pre-processing and extracting key features from the signal. These features are used by AI model to detect heart abnormality and classify disease type. So our pipeline involves signal pre-processing, feature abstraction, deep learning-based classification. This ensures robustness and accuracy. In pre-processing, we apply filter to remove baseline, runner, and powderized interference. This step is crucial to ensure the reliability of level classification. We extract both time of domain and frequency domain feature. Additional convolutional neural network were used to learn pattern directly from the raw signal. And our processing being with ECG pre-processing use wavelet transform to remove noise. Then we extract by feature like RP, QRS complex, and ST segment. Use machine learning, we classify disease type and identify the issue near location too. Here, we show the result of the ECG signal processing use the wavelet transform. In figure 1, you can see the original of ECG signal. It was unstable and pre-baseline, which means there is no interference or noise affecting the signal. In bottom, figure 2, we apply the double T wavelet transform from level 1 to level 4. This allows us to break down the ECG signal into different frequencies. Common component of a multi-resolution analysis. Each level highlights different details of the ECG pattern, which help in detect important features such as QRS complex or noise. This pre-processing step is crucial for improving the accuracy of ECG classification or disease detection. Our model is combined with the CNN for spatial feature extraction and LSTM for temporal sequence learning. This hybrid approach captures both morphology and rhythm abnormality in ECG signal. The model was trained on layered ECG dataset. We apply techniques like data, augmentation, cross-validation, and dropout to avoid overfitting. So we evaluate using accuracy, precision recall, F1 and AUC ROC. This metric provide a comprehensive understanding of model performance. Our model achieved an average accuracy of over 93%. It significantly outperforms traditional machine learning baselines such as decision tree and comparison machine. When compared with the state-of-the-art model, our hybrid of CNN RSTM algorithm shows stronger generalization ability, especially from arrhythmia and ischemia detection. So here you can see an example of model definition versus ground truth. The probability distribution graph shows how confidently the model classification had condition. And this technology can be applied clinical diagnostic support, remote patient monitoring, wearable health device, making healthcare more accessible and proactive. For key advanced include high accuracy, uh, faster diagnostic, scalable to large population, uh, potential integration into telemedicine platform. However, we
मी तर नॅशनल अँथम झाले की थोडं 5-10 मिनिट आम्ही बाईट घेऊन यायचे पर्यंत शिकता का
काय करायचं
depends
म्हणजे फक्त
on
इक्विपमेंट
high-quality
घेताना
data
किंवा कोणत्या मुलाला
potential
एका
bias in dataset.
सगळं इक्विपमेंट
Need for clinical validation diverse
10
population.
मिनिटं खाली पाहिजे
Next, in the future, we plan to expand the data sets multi-sensor data incorporate real-time analysis on wearable device,
शेअर करायचं
work closely
तिथं
with
बसल्या
cardiodynamic
जेवण झालं की असं एवढं गडबड काय राहणार नाही बिल पण तुम्हाला संध्याकाळ
To conclude, our advanced ECG analysis algorithm show the strong potential in improving cardiovascular disease diagnostics by combining AI with with the medicine. We have moved us steps closer to early detection and better patient care. Thank you very much for attending our welcome your person. Okay, if you have questions after talk about to send to my email. Thank you so much.
खाली इथं पटकन ऐक लाईव्ह चालू
Thank you, ma'am. Thank you for sharing your expertise in the healthcare domain. With this and with great pleasure, I announce that IEEE conference IECE2NT 2025 is now officially open. Can we have a huge round of applause for our to rise for the national anthem?
वरती जाऊन फोटो काढ